Hey everyone, and welcome. Today, we're diving into a super powerful way of thinking that's behind, well, pretty much every major discovery in human history. But here's the cool part. It's not just for scientists in white lab coats. It's a practical toolkit that you can use every single day to solve problems, big and small. So let's jump right in.
So I want to start with a question for you. What on earth does a farmer trying to figure out their crops have in common with a scientist on the verge of discovering a new medicine? It sounds like a riddle, right? But the answer is actually pretty amazing. They both use the exact same powerful process of reasoning to get to the truth.
And to see just how this works, we're not going to start in a high-tech lab. Nope, we're going to follow a really simple real-world example. Let's imagine a farmer who's got a very practical puzzle on their hands.
It all starts right here, with just noticing something. The farmer looks out and sees that one field is doing great, but the other one, not so much. And that right there, that simple act of just seeing a difference is the spark. It's the first, absolutely critical step in any investigation. Okay, so our farmer has a clue. But a clue is an answer, right? So how do they go from just a random clue to an actual plan of action? Well, that's where this incredible, structured process of scientific reasoning comes into play.
And here it is. This is our roadmap for the journey. Think of it as the step-by-step playbook that takes you from, that's weird, all the way to, aha, I've got it. We're going to walk through every single one of these steps with our farmer.
First up, observation. Now this is the just the facts stage. It's all about saying exactly what you see, what you hear, or what you measure, without adding any of your own ideas or spin on it. You've got to be a detective here. Just the facts, no stories. At least not yet.
And boom, this is a perfect observation. It's direct, it's measurable. The crops in one field are taller, period. Notice there's no Y in there. It's not field A seems happier. It's just field A is taller. A pure, simple fact.
All right, so once you have the fact, the what, your brain immediately starts trying to figure out the why. And that next step is called an inference. It's basically your first educated guess at what's going on.
And here's the farmer's hunch. Based on that observation, they make a logical guess. Field A might be getting more sunlight. Now this is so important. It's not a fact yet. It's a leap, an educated guess, but it's a great one because it gives them a clear direction to investigate.
Let's just lock this in by putting them side by side because this is so fundamental. The observation is what you see. The plants are taller. The inference is what you think it means. They might get more sun. Nailing the difference between these two is the foundation of clear thinking.
Okay, so our farmer has a solid hunch. But a hunch isn't proof, right? So how do you actually test it to see if you're right? Well, let's see how you turn that idea into a structured, and most importantly, a fair test.
And that brings us to the hypothesis. This is where we take our hunch and sharpen it into a formal, testable prediction. And that classic if-then format is like a magic formula, because it sets up a clear cause and a predicted effect. A good hypothesis is kind of brave, you know? It puts it all on the line and says, I predict this is what's going to happen.
See how clean that is? If I do this, then this will happen. It's so powerful. It takes that vague guess about sunlight and turns it into a super specific claim that the farmer can now actually go out and try to prove or disprove.
Now, to run a fair test, you have to be really systematic about it. The independent variable, that's the one thing you change on purpose. In this case, the amount of sunlight. The dependent variable is what you measure to see if there was an effect. So, the crop height. And maybe the most important part are the controlled variables. Everything else you have to keep exactly the same. The soil, the water, the type of seed. If you change too many things at once, you'll have no idea what actually caused the result.
All right, the plan is set. The experiment is designed. Now our farmer can finally get to work. It's time to run the test and start collecting that sweet, sweet evidence, whereas scientists like to call it data. So, after a few weeks of watering and waiting, the farmer measures all the plants. And check this out. You don't need to be a data scientist to see the story here, right? A simple chart like this makes the pattern just leap off the screen. More sun clearly seems to mean taller crops. And now, we get to the best part, the moment of truth, the big reveal. We have the data, we can see a clear pattern, and now it's time for that aha moment, turning all that evidence into a final, firm conclusion. And there you have it. The farmer can now say with confidence that the evidence supports their hypothesis. It's not a guess anymore. It's a result that was proven with a fair test. You see, a conclusion isn't just your opinion. It's what the evidence tells you. Huge difference.
So, we just followed one farmer solving one very specific problem. Now, I want you to zoom out with me, because here's the secret. Whether you're talking about a field of corn or trying to cure a complex disease, the core process is exactly the same. Sure, a scientist might use an electron microscope instead of their eyes, or a supercomputer instead of a bar chart, but the logic, observe, hypothesize, test, conclude, it's identical.
This whole thing isn't just some academic exercise. This way of thinking is literally how we solve the world's biggest challenges. From developing life-saving medicines to protecting our environment, this method is the engine that drives us forward. It's all about one simple, powerful idea, replacing guesswork with real evidence.
So, there you have it. This isn't some secret language that only scientists can speak. It's a toolkit for thinking. And now, it's your toolkit. You can use it for anything, figuring out why your houseplants keep dying or which route to work is actually the fastest. This process can be applied anywhere. So the only question left is, what mystery are you going to solve first?